So today we are going to see a derivation of motion of a car on a level road. Okay, first we have to start with, we should consider a car. Consider a car of mass m. Okay, which is moving with a constant speed v. I'm considering, okay, on a flat horizontal road of radius r. On a flat horizontal road of radius r. Okay, and let me just draw a diagram to represent this. It is moving in a circular road, which is also a flat road, which is of radius r, and this is the car moving with a constant speed v. If a car is moving in a circular road with a constant speed, so that is called as uniform circular motion. And if there is a uniform circular motion, the direction of velocity changes always. So there will be an acceleration developed, which is directed towards the center, which is called as centripetal acceleration. Okay, so this is the car of mass m and moving with a constant speed v, and the various force acting on the car are a weight which is directed downwards and a normal reaction which is opposite to the weight. Okay, the various forces acting on the car are, so first is the weight of the car, which is mg, and normal reaction which is n, and then a frictional force which is opposite to the direction of force applied. So frictional force, which is small f we are taking, okay, if it's moving towards this, and the frictional force is opposite to the direction of force applied. Okay, so acceleration, no acceleration in the vertical direction. There's no acceleration in the vertical direction, therefore net force is 0. Net force is equal to 0, and vertically the forces acting are n and mg. N minus mg is 0, so normal reaction and weight of the car both are equal. So next, the centripetal force. Centripetal force required, or centripetal force required for circular motion. A centripetal force which is required for the circular motion is provided by the static frictional force here. Okay, is provided by static frictional force. So in equations if we write, centripetal force is mv square, and here v is the maximum speed that a car can accumulate in the horizontal road, and v square max by r. R is the radius of the car, as we know, and f max. Okay, so f max is the static frictional force. We know that static frictional force is equal to mu s n. Okay, so and next, on substituting that, mv square max divided by r is equal to mu s n, and as we know that n is equal to mg. Here in equation 1 we have written that. So mv square max by r is equal to mu s mg. So mm on both sides will get cancelled. On rewriting this, v max is equal to mu s, r will go that side, so it will become r in the numerator, and g and square root. So v max is mu s r g. Okay, so where mu s is coefficient of static friction. Coefficient of static friction. So okay, for a given value of mu s and r, there is a maximum speed of circular motion of a car possible. Okay, only this much is the derivation for motion in a car on a level road. Okay, motion of a car on a level road.